Okay, lesson 66 is on rational exponents. Rational also means fractions, so we're talking about fractional exponents. And the idea to this whole lesson is the idea that radicals and rational exponents are one and the same thing. So for instance, if I said that I had x to the 2/3 power, that's the same thing as saying, let me zoom in here, that this right here is the radical, or the root, and this up here is a power, or an exponent. So if I'm going to rewrite this in radical form, it is x squared, because that's the power of the exponent, on top, so it's x squared, underneath a third root. Or you could also write the root first, it doesn't matter. So I could say that this is x underneath a cube root, a third root, with a square on the outside. Those are both true. If I wanted to convert in the other direction, if you told me, for instance, that I had an x, or rather, let me use a different letter, let's use m to the fourth underneath a fifth root. I know that the power is going to go on top, so I know that I have m to the something over something. I know that the 4 is going to go on top, and I know that the 5 is going to go on the bottom. Okay? So that's, in essence, the skill being taught in this lesson. Let's do a couple of example problems. On the front, all we have to do is rewrite them. So if we're rewriting this in fractional exponent form, I know that this right here is the power, and this right here is the root. So this is going to go on top, and the root is going to go on bottom. It's the numerator and the denominator. So I have 7 to the 2/3 power. And that was the only instruction that was really given. Rewrite it in exponential form. So this right here would be 3 to the 2/3 power. Simple. Alright, so let's do one that's a little more complicated. The last one on the page here, 16. A 1 over something, that means that our exponent is going to be negative. Negative exponents get us reciprocals. We talked about it in the previous lesson, we've talked about it since. So here's the idea. Let me handle the bottom first. This is going to get me 2k underneath the 6th root raised to the 7th power. That means that this right here is going to be the denominator, and this right here is going to be the numerator. It's going to go on top. So let's rewrite this. I've got 2k to the 7/6 power, and then this guy here, the 1 over, that's going to make it negative. And that's my final answer. Let's do one or two from the back. Write each expression in radical form. The radical is also square root, or roots in general, or radicals. So if I'm doing this, question 17, I have 7v raised to the 2/3 power. So remember, this is going to be the power, or the exponent, and this is going to be the root. So it doesn't matter which one you want to write first. I usually do the root first just because I would rather shrink something before making it bigger. It's easier to deal with those numbers if we were evaluating. So what I'm going to do is I'm going to say 7v underneath a third root raised to the 2nd power. Let's do another one. 19. I have 3n underneath a 4th root raised to the 1st power, which you don't actually have to write at all. It's usually like that. And let's do one with a negative. Do I have one that is separated? No. Okay, cool. So let's just do a negative, 21. So I've got 10x underneath the 4th root raised to the 7th power, and then the negative sign tells me to put a 1 over the whole thing. Now this is in the denominator of a fraction. Lastly, the homework section was asking you to rewrite and then evaluate, so we did some of these examples in class. I'll just do 2 of them. I want to rewrite it in radical form. So 81 underneath the square root, which doesn't actually need to have a 2 written here. It can be implied. Raised to the 3rd power. And then the negative sign puts the whole thing under a 1. Now let's evaluate this. What's the square root of 81? Well, that's 9. So I've got 1 over 9 cubed. 9 times 9 times 9. I might want a calculator for that. Well, I wouldn't, but you probably would. So let's do it for, on there. 9 cubed is 729. So the final answer is going to be 1 over 729. And that's how I can use the properties of rational exponents to evaluate something that otherwise I would need a calculator 100% to be able to do. So let's do another one. It's slightly more complex. Question 28. I've got 27 underneath a cube root to the squared power. Now here's the thing. What is the cube root of 27? I'm going to go to my calculator here, and I'm going to show you, in case you didn't know that it's here, that you can take any kind of root. First thing, under the math menu, I can go down, and option 4 is actually a cube root. So option 4 under the math menu will allow you to cube root any number you want. But I want to show you this one here, option 5. That's a root with a little x next to it. That will allow me to take any kind of root that I want. If you want a 4th root or a 5th root, all you have to do is this. I put what kind of root I want, then I go to math, option 5. That right there is a 3rd root now. So if I wanted to do the 3rd root of 27, that's how I would type it in. So it turns out the 3rd root of 27 is 3. If you wanted to do something a little crazier with it, if you wanted to do, for instance, the 4th root of something, which is not an option in the menu, the 4th root means you put down the 4 first, you go to math, you go down to option 5, that right there is a 4th root. So if you want to do the 4th root of something like, I don't know, let's say 81. I can find out that the 4th root of 81 is also 3. Hopefully that helps you in the future, that little trick. So when I go to rewrite this here, the cube root of 27 was 3. So 3 squared is equal to 9. So try some of these on this page, ensure that you are good, and make sure that you are prepared for the next lesson.